Hey everybody, this is Mr. Walsh, and today we're going to be going over the Electron configuration, and we're going to continue on from the underground hotel that we were working on, but now we're going to move along from the hotel to making this more technical and making sure we talk about Electron configuration. First, realize why we're doing this. Why are electrons such an important thing that they have their own configuration and things like that? Well, first of all, before we even talk about this, realize that the structure of the atom has the nucleus in the middle and the electrons are on the outside. So the electrons being around the outside in the electron cloud make the electrons easier to manipulate. Okay, and so the electrons are arranged around the atom. They are not just kind of willy-nilly put in place. It's not like a dump truck comes along and then dumps electrons into the atom. Okay. Turns out that electrons have a specific arrangement. Okay. And the other part of that is that electrons control almost all the chemistry, with the exception of what we call nuclear chemistry, okay, which you would know from like nuclear power, nuclear energy. With the exception of nuclear chemistry, electrons control the chemistry of an atom. Okay, so if we kind of have an idea of the arrangement from point one, if we know how they're arranged, we can kind of predict and kind of figure out what their chemistry is going to be, point two. So it's kind of like, if we know where the electrons are, what rooms they're occupying, then we can figure out, how these elements are going to react, how these atoms are going to do things. We're going to talk about ground state and excited state. When we're dealing with the hotel, and we're gonna get away from using hotel as a thing, but for now we'll be okay. We were talking about it following the three rules. Okay, the three rules closest to the lobby don't pair unless they have to, and then if they're paired, they have to spin in opposite directions. Okay, so if they follow all three rules, we call that the ground state, right? It's our underground hotel. And so the ground state is when all three rules are followed. But in excited state, remember we were talking about how the fire marshal would get excited, okay, if we broke the rules. Well, if the fire marshal gets excited because we're breaking the rules here, then that's what we call the excited state. And there's a lot of different ways that we can break rules, and it doesn't have to be just one. It's just at least one. Okay, so sometimes all three rules are broken. Sometimes two of the rules are broken. But the important thing is that ground state is when it follows the rules, and excited state is when at least one of the rules is broken. This is what we call an orbital box diagram. Okay. So we have, instead of the two-dimensional hotel, now we've lined up all the rooms together. And so like this is one room, this is a set of rooms, this is a set of rooms, this room, and then these together. And so that way you know how to kind of group these things. Okay. So if we look at this first as an example, you will see that this is filled correctly. We have two electrons in the 1s, two electrons here, and they are facing in opposite directions. This is filled, and now the one extra electron is here. Okay, so now if we look at this, so this is a ground. This is what we call a ground state. Follows all the rules. If we look here, you can see this looks good, this looks good, this looks good. And now this is empty, so this electron should actually be here, right? Remember, we have to fill closest to the lobby first. Closest to the lobby, meaning the ground here. And so we want to fill here, okay, before we fill here. So this breaks the rules, so this is an excited state. Okay, so now you know the definitions, now you know you have an example. So what if we did this? Okay, maybe you want to pause the video and see which one's the ground, which one's the excited state. Okay, we're going to go over this. This is the excited state here, this one. This one is the ground state. Okay, this one's excited because here, this should be here and pointing upside down. Okay, this one is the ground because it's filled all the way kind of perfectly. Not all the time are we going to get orbital box diagrams. Sometimes we're going to see this arrangement. This is the report that we were talking about. Okay, but this report is what we call the electron configuration. Okay, so that's our first movement away from the hotel terminology, and so this is called the electron configuration. That's the chemical terminology for this. Okay, so again, you may want to pause the video and see if you can do this on your own. And now we will go over the answers. So we have here, is this filled correctly? 1s2, 2s2, 2p6, 3s2, 3p4. Yes, all of these are filled in order. There's no skipping. They're filled all the way out. So this is a ground. I'll put a G here for ground because this ain't nothing but a G thing. Okay, and now we have this one here, 1s2, 2s2, 2p5, 3s1. So this isn't filled and this isn't filled. And then we went here. So it's like the electrons need to come back and fill these a little bit. So this is an excited state. Okay, and then the last one here, this is filled right, 1s2, 2s2, 2p6, 3s2, 3p2. Okay, just snuck that in there. Remember, in the p's we can have 6 electrons and not just 2. So this is an excited state. These 2 electrons should move over here, and then you shouldn't have anything in the 4s. Okay, so now that we know excited versus ground, let's talk about how we are going to take the hotel. This is kind of the hotel terminology, and then these are the chemical terminology. Okay, so when we do this, and this is weird looking, it's not part of the way the camera is going. This is because I took the hotel, which was in portrait, and then I stretched it out, put it in landscape so it would fit in this presentation. So that's why it looks a little strange. Okay, and again, it's kind of cut off here, cut off the top, but that's okay. So let's look. Okay, so in the hotel, we would say that the lobby, we wanted electrons close to the lobby, right? That was our rule, close to the lobby. So we're not going to say the lobby isn't actually a lobby. The lobby is the nucleus. So when we fill electrons, we want the electrons to be closest to the nucleus. Okay, so if we have and I'll put it here, if we have the nucleus, and then I'll just use the Bohr model. Okay, and we'll put a couple of rings here. So if we have a choice of putting an electron somewhere, we're not going to put it here. We're going to put the electron here on the closest ring or floor, which brings us to our next word, which we use. So we had first floor, second floor, third floor, fourth floor. That's actually called an energy level. Okay, so this is not a ring. It's not a floor. This is the first energy level. So on the periodic table, you can see that we have, okay, this is the first period, but it also represents kind of the first energy level, the second period, the third period, and the third energy level. Now in the fourth period, we do have fourth energy level, but then we also have the 3 Ds here, so we have to be careful thinking that this is the fourth energy level all the way across. The 3 Ds are a little offset, and then 5, 6, 7. Okay, so the point is that we can see the energy levels on the periodic table. Okay, and then the energy levels are divided. So here you can see that the first energy level just has a studio, but the second energy level, okay, I know that it's like crooked. Okay, the second energy level is divided into the studio and the pad. Well, these divisions are called sublevels. So if I look at this thing, the first energy level isn't divided, but the second energy level is divided. So you have the S region of this, and then the P region of this. Okay, and then the sublevel is divided into rooms. So the P sublevel has 3 rooms, but we call those orbitals. So if I'm going back here, and this is why the Bohr model breaks down, is that, let's see, we have like a room here in this sublevel, okay, and then in the P sublevel we have 1, 2, 3 rooms, 3 places where we're going to put electrons, okay. On the first energy level, we only just have 1 room, okay. And the last part of this is spin. When we filled a room here, we would put electrons facing up and facing down. Well, it's not that they face up or face down. What it is they spin, like we have this thing, they spin around this way, the electrons do, okay? And then then sometimes they spin the other way. And the only way that electrons can occupy the same orbital is if they spin in opposite directions. That's the rules of chemistry, right? And so so that's why we do spin up and spin down, or pointing up and pointing down, is because that's the only way electrons can occupy the same place. Okay, so these are the hotel terminology, and we're going to start substituting in the chemical terminology here to make things a little easier. And then lastly, before we get into some example problems of this, okay, what do these orbitals look like? Well, the s orbital is a sphere. So look, I'm going to take and I'm going to draw kind of what the electron is doing here. It's kind of moving around, and this is on the first energy level, and that's an S sublevel. Okay, and that's spherical. So this is a spherical thing covering up the spherical orbital covering up the nucleus. And now, if we go to the 2s, okay, like back here, okay, this is the first energy level. Now we go to the second energy level. The difference between the first energy level and the second energy level is size. So the 2s is going to be a bigger thing as the electron moves around. It's going to be another sphere, and again, remember, they come up kind of into the camera and then down into the table here. Okay, so then you have an S, and then the 3s is another sphere, because the s's are spheres. Okay, and it's going to be even bigger. Okay, and so you have these electrons move around, and again, it moves through. So what you have is like those Russian nesting dolls, where you have a nucleus in the middle, then you have maybe a golf ball. So this is maybe a P, and then a hollowed out golf ball, like a tennis ball, let's say. Okay, and then around the tennis ball is maybe like a hollowed out softball, and then around the softball is maybe a basketball. Okay, and then if we had to go up to the 4s would be even bigger, and that would maybe around the basketball maybe a beach ball. Okay, and then it can go to the 5s, which is bigger and bigger and bigger. So the difference between a 1s and a 2s is the size. Okay, s orbitals are spheres. Now the p orbitals, I'm going to say this, they look like dumbbells. That's chemists all over the place say that p orbitals look like dumbbells. I don't know if that's the case, but if you look, okay, it's kind of like 2 teardrops put together. What I'm going to say, so that you remember the word P, or the letter P and its shape, is I'm going to say that p orbitals look like peanuts, like raw peanuts, right? And so P is a peanut. And then the D, chemists will say that these things are clovers. Okay, they kind of look like a 4-leaf clover here, or like a whatever that is. But in order to remember D, I'm going to say that these look like double peanuts. Okay, and that lets you know what S, P, and D looks like. Okay, now if we were looking at the F orbitals, okay, those are the only other ones that we have. And I'm not going to make you know that, but the F orbitals, I don't know, they're like double clovers, so they're like that are double peanuts. Like they're all this weird thing where stuff. So f orbitals look like flowers. Okay. All of this is to get us to be able to do electron configurations. And so let's take a look at electron configurations and what we kind of need to do for that. So we're going to look at the periodic table. Okay. And I have my periodic table here. Let me make some room here. And so we'll cover these up. Okay. So what we're going to do is we're going to start with lithium. Now lithium, if we look at the periodic table, is right here. And lithium has 3 electrons. Okay. When we did the hotel, we had teams coming in with different numbers of players. Well, now instead of teams, we have elements, and the elements have different numbers of electrons. Okay. And we have to put those electrons someplace. And so this is what the periodic table is telling us to do. We're going to start at the first energy level. Okay. And if you need the hotel, feel free to get out the hotel to do this. Okay. But just try to substitute, instead of saying the first floor, substitute and say energy level. Okay. That's my abbreviation for energy, NRG. Okay. Energy level. Okay. But we're going to do this here for the periodic table. Okay. So here's what we're going to do. We're going to start on the first energy level. Okay. And on the first energy level, the letter we have is an S. And then how many? S, 1, 2. Okay. So we will do 1s, 2. And now, that puts us here. Are we at lithium yet? Okay. No. And do we have any elements on this side of helium? No. What we do is we use the periodic table and we go down to the next energy level. So that's going to be 2. And this here, this side of the periodic table, is the S block. So we're going to do 2s. And then how many over is lithium? It's 1 over. I'm putting my finger right on it. So that's going to be 1. So we do 1s2, then 2s1. Okay. Now that's a shorter thing. Let's build our way up. So boron. Boron. If we look at boron, boron's here. It has, let's see if I can do this in a way that we can get that on there. Yes, look, we'll do it like this. Okay, so here's boron. Okay. Boron has 5 electrons. Okay. So we're always, like we did in the hotel, every time we had a new element, we would start back over at the very beginning and we would fill in the electrons. Every time we had a new team come in, we would fill in the people. Okay, so every time we have a new element, we're going to start at the very beginning. So we start up here. What energy level? 1. What block? S. And then how many? 1, 2. So we're going to do 2. Okay. And now, again, there's nothing over here, so we're going to come down here. So to the second floor, just like we did up here. Okay. We went from 1s2 to 2s. Okay. Same thing. Pattern's going to be kind of the similar thing here. So we go 2s, 1, 2, and that puts us at beryllium. Have we gotten to boron yet? Not yet. So now we're going to go all the way across here. And we're going to go to this element here. So this is 2. And then this block over on this side is the P block. Okay. And then how many over is that? That's P1. We counted over 1. Okay. And so that is the electron configuration of boron. Now, same thing with magnesium. Okay. I say same thing, but I mean, we're going to use the same process. Magnesium is here. We have now 12 electrons. Okay, 12 people on the team. And we have to start at the same place every time. We're going to go 1s, 1, 2. So that's here. Nothing over here. So now we're going to go down to the second energy level. 2s, 1, 2. We haven't gotten to magnesium yet. We're only here at beryllium. Now the big gap brings us over to here. So that's 2p, let's see, 1, 2, 3, 4, 5, 6. Have we gotten to magnesium? Not yet. So that's 2p6. And then we come down here. Okay, there's no more elements on the side. So to get to magnesium, we got to come down another energy level, 3. And this is the S block, S. And then to get to magnesium, we're going to count over 1, 2. So 3s2. Okay. We can do this for all of these. Okay. So maybe take a minute and pause the video and then see if you can do phosphorus here. Okay. So again, start at the same level. 1s2, 2s2. We haven't gotten to phosphorus yet. 2p, 1, 2, 3, 4, 5, 6. We haven't gotten to phosphorus yet. Okay. 3s. Okay. 2. We haven't gotten to phosphorus yet, so now we're going to take the big leap over here to the 3 p's, and then to get to phosphorus, we're going to count over 1, 2, 3, and now we're at phosphorus. Okay. Same thing with argon. We're going to come down here to argon. 1s2, 2s2, 2p6, 3s2, and then 3p, 1, 2, 3, 4, 5, 6. Okay, and then lastly is potassium. So potassium is interesting. Not too much, but potassium is here. So we're going to go 1s2, 2s2, 2p6. That puts us over here. Now 3s2, 3p6, and this is where the periodic table helps us, because if we're using here, people get confused whether we're going to do the 4s, or whether we're going to do the 3ds first. Okay, well, what does the periodic table tell us? The periodic table says we go down to the 4th energy level, and we're going to go to 4, and now we're in the S block, so we're going to go to S, and then we're going to put a 1 there. We count over 1, and that gets us to potassium. Okay, so that's pretty wild. Okay, so this is going to be part 1 of this video. We're going to continue on with this lesson. We're going to talk about the types of electrons and stuff like that, and Bohr model in a little bit. But I wanted to get through how to relate what we did with the hotel to doing electron configurations. Okay? Have a great day, everybody.